In this problem, it asks about the compressor blades in a jet engine, and we know we have a diameter of 42 centimeters. So first we have to convert that into meters, and from 42.42 meters, we can say that we know that we have half of that, which is 0.21 meters as our radius. We also know that we have a frequency of 15,960 RPM, and the reason I've written it this way is what we want to do before we can put it into a formula is we want to change it to hertz, which means what we're doing is we know that we have 1 minute in 60 seconds, and then we know that we cancel out the minutes, so we're doing 15,960 divided by our 60 seconds, and we know we're going to get 266 cycles per second as our frequency. This question is asking for the magnitude of centripetal acceleration, and we know that we can do 4 times pi squared times our radius and frequency squared in order to get our centripetal acceleration. So if we put all our numbers in, 4 pi squared times 0.21 multiplied by 266 squared, we are going to get 5,86600 meters per second squared. In order to put it into significant digits, we switch it to 5.87 times 10 to the 1, 2, 3, 4, 5 meters per second squared. Our second example asks about a 700 kilogram roller coaster that's going around a vertical loop, and we know the diameter is 50 meters. That means that we also know dividing it by 2, we have 50 meters divided by 2, which means that our radius is going to equal 25 meters. What it's asking for here is it's asking for the minimum speed that the roller coaster can go. That means the slowest possible speed it can go. And we know that the slowest possible speed it can go is when Fc is going to be equal to Fg. Any roller coaster problem we have, we know that our Fc, our centripetal force, is going to be equal to our Fg plus our Fn. But our Fn, if we want the roller coaster to go as slowest it possible can be, our Fn is 0. Our Fn being 0, that means that our Fn does not need to exist, which means the track does not need to give a force to the roller coaster. There could be a hole in the top of the track. So we could have a track that looks essentially like that, and the roller coaster would still be okay. Okay, so we know that Fc is equal to mass times velocity squared divided by r, and we also know that Fg is equal to mass times gravity. So we can set those up equal to each other to calculate our speed. So here I've set them up equal to each other. What I have on the left is my Fc, and what I have on the right is my Fg. So now I'm going to calculate for speed. Because I have mass on both sides, I can cross out my mass because it would be doing the same thing on both sides. I can multiply both sides by r, and that gets rid of the r on the left-hand side. And then what I'm left with is v squared is going to equal g multiplied by r. So I know that my g is 9.81 meters per second squared, and I also know that my r, in this case, is 25 meters. This would give me that v squared is going to be equal to 245.25 meters per second. In order to get rid of my squared, I'm going to square root both sides, and that will give me that v is going to be 15.7 meters per second. And that's the minimum speed for the roller coaster. This last question is asking about a bucket of water when it's at the bottom of a circle. So if I were to draw a free body diagram of this, and I were drawing my bucket of water that's being spun around in a circle, I can draw my bucket of water down here at the bottom, and I know that the force is acting on my bucket. There's always going to be gravity acting on my bucket, so I can say Fg. And then the only other force that's acting on my bucket in this situation is going to be the force of tension, which is Ft. And Ft is what we're looking for, so I'll give it a circle. That's our question mark. So we know that our centripetal force, which is Fc, is going to be equal to our F net, because that's what's keeping it in the circle. So all of the forces added together have to equal whatever is keeping it in the circle. We also know in this case that our F net, or our Fc, has to be equal to both of those two forces that we have added together. So we have Ft and Fg. To solve for Ft, we will say that Ft is going to be equal to Fc minus Fg, because what we've done is we've subtracted Fg on both sides. So now, just like the last question, we know that our Fg is going to be mass times gravity, and we also know that our Fc is going to be mass times our speed squared over our radius. So we can put those into this formula. So over here, I know that my Fc is going to be mass times my speed squared divided by my radius minus my mass times my gravity. When I put in my numbers here, I have 1.5 multiplied by 3 squared divided by my radius, which is 0.75. From that, I'm going to subtract my mass, which is 1.5, and my gravity, which is negative 9.81. And I'm going to get here 32.715 newtons. And to put into significant digits, I will have 33 newtons is my force of tension.